guys, let me try to catch up a little bit. So just looking at the 4 groups, are they the same sets of data?
Absolutely.
Hell no. Obviously, right? Group A is much more clustered in the middle. Group D is like not in the middle at all, right? So would you say each group of data is the same? No. Does that agree with what you found in number 1? No. Because in number 1 we saw everything we calculated was the same for all of them. And that doesn't mean they are the same. That just means we haven't figured out enough ways to measure what's happening with each data set. There is a difference. We just haven't, our measures of center can't get those differences. Okay. All right, I like it. So then number 3, I'm trying to give us a visual of what's going on. So if I do the, Jeff, should have wrote it up here again. 6 through 8, 9 through 11, 12 through 14, 15 through 17, 18 through 20. So for A, how many things are 6 to 8? 1 thing, yeah. And then it goes none here, 8 here, none here, 1 there, if I remember correctly. Is that right? Yeah. You guys see that? And all I did was, there's 1 thing 6 through 8, nothing 9 through 11, 8 things 12 to 14. I'm sorry. 8 things 12 to 14, and then 1 thing that's up at the end, right? So it's just the frequency distribution that I'm asking for. What about for group B? There's still 1 thing here. Maybe zoom out a little bit, maybe there. There's still 1 thing 6 through 8, but how many things 9 through 11? 2, right? 10 and 11. How many things 12 to 14? 4. And then 2, 1, if I remember correctly. They all should be symmetric like that. And then C is the crazy one. 2, 2, 2, 2, 2. Okay. And then D is the one that's very adventurous. All right, there's 3 here. I think there's 1 here. Is that right? 2 here, 1 here, 3 there. Is that right?
Yeah.
Okay. So real quick, if I think of, let me see if I can make this make sense. If I think of the mean as home, which data set has the most data points further away from home? Well, let's start with this one. Which one has the most things close to home? No, come on. If the mean is home, what's the mean? What did we figure out the mean was? 13. So which data set has the most things close to home? A. It's got 8 things still in the house, and the parents are like, move out. Right? Now, which one has the most things furthest away from home? You could do it. It's totally D. It's not C, because D has 1 more thing further away, 1 more thing further away. So let me ask it a different way. Which set of data seems to be the least spread out from its center? The least spread out from its center. Where's the center again? 13. So which one gets the least distance from its middle? A. Do you guys see that? There's 8 things right on the middle. Yes? Which one has the most spread from the center? The thing that has the most data points far from the center? D. Okay. So what we're working towards is I want 1 number that will tell me how spread out from the middle the data is. So if I tell you, so real quick, let's do an actual example. Do you guys know about the silly website called Rate My Professors?
Yes.
Did you guys know there's another website that you have to pay money for, but it actually tells you the grade distributions of every teacher at your school? So you can look me up and see how many A's I give on average in my stats classes, for example, and B's, C's, D's, F's. You guys know that that's out there? I'm not going to tell you what it is, but you can go pay money and do it if you want to, because it's actually public information. You can actually call the school and say, I want this data, and they have to give it to you. It's public information.
No,
Yeah, but you have to do the work. I'm not going to do it for you. So, real quick, let's say that you were looking at two teachers. They're basically the same on rate my professor. And you look at their grade distributions, and they each give an average of a C. Each of them. You with me? The average grade they give is a C. One teacher, let's say you're at university, to make this make more sense. Because what's different at university than in community college? What's failing here? Anything below a?
Anything below a D.
Well, a C, because D and F doesn't transfer, yeah? So in terms of what you really need, that's failing below a C. You could retake it if you make below a C. At university, what's failing? F.
D for degree.
So you could get a D and pass the course in university. You guys with me?
D for degree.
So let's say you're going to university. There's two teachers. They both give an average of a C. This teacher gives B to D. And this teacher gives A to F. So their average is the same, just the spread is different. Are you guys sort of with me? Now could you determine which teacher to take? Well, let me ask you, when would you take the A through F teacher versus the B through D?
A through F and D through
No, not which college. You're going to university, period. So when are you going to take the A through F teacher versus the B through D? What's going to suck if you take the B through D and you kick its ass, that course's ass? It doesn't seem this teacher gives any A's. And I took a teacher like that. And I kicked the damn course's ass, and he gave me a B. And I'm fine. Sorry.
This is how long ago? It's still keeping
20
you up at night?
How long is that? 16, 17 years? At least?
I'll never think
Anyway, sorry. So, I am going to take the A through F class. When I feel pretty good, I'm going to kick that class's ass. Because then I'm going to get that A. I might take the B through D if I'm like, oh shit, I might fail this sucker, and it looks like this teacher doesn't fail people. Does that make sense? No, to be really honest, you should take the class you're going to learn. But right? Okay. Maybe. So, if I know the middle of a data set and how spread out it is, those two numbers give me a lot of information. You don't have to show me the whole freaking data set. Just give me those two numbers, the mean and the spread. And then I have a really good idea of what kind of it looks like, what's going on. So that's number 4. They don't reflect the differences in the grade distribution. So the differences that the measures of censor can't get is how spread out the data is. Not spread out at all, much more spread out. Right? So the last thing we're doing today, and I've left myself just enough time to do this. I want to develop the math, and we're going to do this together. So it's going to be so exciting. This is going to be sort of like making sausage together. So you're going to see where this formula comes from. And hopefully you're going to agree with me, the formula. And if you don't, too damn bad, because somebody already created it. We have to go. But I want it to make sense where this formula came from. So you're so used to, here's a formula for this. Now put shit into it. You're not used to, I don't know, let's make a formula. That's basically real math. Is I don't know, let's make a formula. Okay. Somebody click on the light switch. There's only one that should be. Thanks. All right. So let me give us 2 sets of data here. Group A and Group B. Just 2 sets of data. Let's say this is what do you got, Jeff? 3, 4, 4, 4, 5. Sure. And then this one will be, yeah, it's not quite doing what I wanted to, but it's fine. 2, 3, 4, 5, 6. Okay. Do you agree with me they both have an average of 4? Can you guys see that? Anytime the data is perfectly symmetric, the median and the mean are the same. So, they both have an average of 4. Let's say these are populations. They're very tiny populations. So, they both have a mean of 4. Which one gets away from the mean more? Which one has more data that gets away from the mean, that leaves home? B. So whatever we're about to do, the number we're about to calculate better be bigger for B, or we can throw that shit out and then basically just stop taking statistics because it's the underpinning of all we do. So that's where I get a little nervous that I'm going to make a mistake and it's not going to work right. Oh, damn it. Okay. So we're going to do part A together. I'm going to have you guys do part B. Okay. If we have enough time, we'll see. So let's write it like this. Let's write this a little bit better. Let's write the data. So let's look at group A. Let's see, that's right, yeah. 3, 4, 4, 4, 5. So let me ask you something that seems disconnected, but if I want to know the average age in this class, what's the very first thing I have to do?
I don't know what.
No.
Find out our age.
Get everybody's age. Yes? Then I can add them. If I want the average shoe size, what's the very first thing I have to do? Get everybody's shoe size. And then I can add them all up, divide by how many people. Yes? This is getting silly. Do you agree with me? So here's what I want this number to do for me. I want this thing we're about to calculate, which is the spread. I want it to tell me, let me say this. I want it to tell me the average distance from the mean to all the data points. Doesn't that kind of jive with what we were talking about earlier about who gets away from home more? So if I can figure out, on average, how far from the middle do the data points get? If there's a bunch that's collected here, that number is going to be small. On average, they don't get very far away. If there's more that's away from the mean, it's going to be bigger. Let me write this down. So I want the spread to be the average distance from the mean to each data point. That's what I want this number to do. I want this number to tell me that. And that kind of jives with what we want spread to be. Okay, maybe, does that definition make sense? You guys understand? If on average it gets further away from the mean, it's going to have a bigger spread. So if on average, if the average quiz grade was 76, which is what it was, no, 68. The average quiz grade was 68, and then the spread was 20-something. That means on average, each data point got 20 away from the middle. So some might have been 3 away, and some might have been 40 away. You guys follow? That's just on average how far from the middle it got. Okay. So listen. If I want to know the average something, average shoe size, average age, I first have to get a list of those somethings. Yes, we all agree with that. So, for example, how far away is this data point from the mean? 1. It's 1 away from the mean, right? So what I'm going to do is I'm going to do something very specific. I'm going to write that. Now that is missing something. So what is 3 minus 4? Negative 1. 4 minus 4? 0. Is everybody cool with that? So that's the data point minus the mean. So those all got 0 away. Negative 1 means it's 1 below. Are you with me? So the negative does mean something. And 5, of course, would be 1. Does everybody see where those numbers came from? The mean is 4. So each data point, 3 minus 4, bam. 4 minus 4, bam. 5 minus 4, bam. What do I get when I add those up?
It's 0.
You will always get 0 right there. If you take each data point minus the mean, it'll always equal 0. There will be equal amounts negative, equal amounts positive. So if I just stop there and I average that column, it's always going to be 0. It's not going to tell me shit if everything in the world is 0. That's not going to help me, right? So one thing you might think, do you guys remember what distance is in algebra? What function do I use to get the actual distance? Absolute value. You guys remember that? Absolute value is distance. That's why the absolute value negative 4 is positive 4, because it's saying how far from 0 is negative 4. So you can't say somebody's negative 4 feet away from you, because that would be like they're inside and Quaid, right? That would be weird. Distance is positive. So you might think let's just take an absolute value. That's not what we end up doing. And just to explain really quick why we don't, do you guys remember what an absolute value looks like? If I graph it, does anyone remember? Not a parabola.
What's a V?
It's a V, because it's linear still. It's not squared, it's not cubed. So it comes in like an X, and then it goes out like a negative X. Amen, like it? No. Would you want to be on that plane if this was the flight path of a plane? Right? Everything's going fine. I'm glad you can come. And bam! You know, everybody's dead. Right? So in mathematics, this is bad too. This is what we call a kink in it. That's so much bad happens at that freaky ass point. The slope suddenly completely changes from -1 to 1. Just bam, right? So we don't like that. That kind of messes up a lot of our mathematics. So what we do instead, we still want the negatives to become positive. So what we do is we square it. Which means, what am I going to have to do at the very end? Square root it. So that overall it didn't do anything. So if I square these, so what I'm going to do, so technically, this directly would mean add up all the distances divided by n. But there's a mathematical reason we stay away from absolute value. So instead what we're going to do is we're going to add up all the squares of the distances and then square root them. I really want this to make sense. If I add something, so anytime you see something divided by n, that is the average blah, whatever the hell that is. If I add up the number of pets people have and divide it by the total number of people, it's the average number of pets, right? So this will be the average distance, square root and square cancel, average distance from the mean to the data points. So now what do I get when I add these up? Incredibly enough, I get 2. So if I do that formula, and the symbol we use for this, the funny thing is, it's not because of the word spread, it's because what we're calculating is called the standard deviation. That's why we use the lowercase Greek letter s. We use lowercase sigma. And here's what lowercase sigma looks like. It looks like R that's eaten a lot. So what do I mean by that? It looks like this. Sometimes I'll draw it like that, right? Big old fat R. Sometimes I'll draw it like that, little skinny R, right? That is the Greek letter S, lowercase. Remember, uppercase was the E, right? You guys with me out there? You guys see how to draw that? You start from the inside and you go out like that? Okay. That's the Greek letter S. That stands for standard deviation. So now if I just throw this into the formula, square root, what was the, now here, this is where you guys, the algebra gets a little in your head and you start making mistakes. We're so used to plugging shit into each individual thing. But what was the sum of these? That there's one number that goes in there for the whole thing. What was the sum of these? 2. You don't put shit in for x. You can't, because x is all of these. You can't put a number in for x because it's a bunch of different things. But the sum of this is 2. And what's n? What's n? How many data points are there? 5, okay. All right, so somebody help me out. What is the square root of 2/5? 0.4, so 0.63. So you gonna help me out? You guys all have calculators now, right? What is the square root of 2/5? Square root of 0.4. Holy shit. All right. All right, you guys aren't going to tell me. .632, I think, is it, right? You guys getting that? .632? So real quick, look, how far is 3 away from the mean? 1, yes? How far are the 4s away from 0? How far is 5 away from the mean? 1. So roughly on average, they get about .632 away from the middle. That's a rough idea of what the average is. The fact that we squared and square rooted doesn't really make it match up exactly, but we just had to. If I did all this work again for this data instead, would I get a higher or a lower number? Because for this one, do they get further away from the middle? Yes, right? Don't the data points get further away from the middle than the first one did? Okay. What time we got? Shit, I gotta go. Let me give you this. So there's a handout here. There's more stuff. We still have to finish this up. There's still some other questions, but I want you to have this. It's got an example of what we just did. There's one little thing that's different here. Let me see if I can talk about it real quick. Oh, I got no time. Let me see. How do I say this real quick? So you guys, you're a population. Would you all agree there's an average age in here right now?
Yes.
Yes. Would you all agree that every one of you is some distance away from that average age?
Yes.
Yes? Probably I'm the furthest. But, all right. And I definitely am an ally. If I took a sample from you guys, let's say I take you 4, would their average age be the same as everybody's, the average age of everybody? What do you think?
No.
I would put money, and I'm a teacher, I would put lots of money on the bet that their average age is different from everybody. Are you guys with me? Right? Would they, as a group, be closer to the average of them, or would they be closer to the average of everybody? You can think of it, you can do this. I put you 4 and I get an average for you guys. Would each of your ages be closer to that average, or would each of your ages be closer to the average of everybody? They would be closer to their own average, correct?
Yeah.
So, this is for a population. Greek letters very often mean population. If I did it for a sample, what I get is going to be smaller than what it should be. Based on what we just said, you guys are automatically maybe closer to the own average, not to everybody else's. So the thing we do when we have a sample is we don't divide by n, we divide by n minus 1. Because the answer is smaller than it should be, we divide by a little less to make it bigger. Now there's a lot more behind n minus 1. I'll get into it next time, but just in case you look at this worksheet, you'll see this formula, not this one. This is for a population. This is the adjustment if it's just a poor little sample. So it's going to happen a lot this semester. There's going to be a formula that adjusts a little bit if I'm in a certain situation. All right, but again, we'll talk more about that next time, but I just wanted to point that out. So if you have any questions, come up and see me.